So when we talk about number system, simply when we talk about numbers, there are two things. One is imaginary numbers and the other one is real numbers. So from exam point of view, there's no question asked from imaginary numbers, so I'll be focusing on real numbers only. So when we talk about real number, under real number can be divided into two things. One is irrational number and the other one is rational number. Let me give you a short definition of what is rational number and what is irrational number. So rational number means, in simple words, any number which can be written in P by Q form such that Q is not equal to 0. Which simply means any fraction, 2 by 3, 4 by 5, or 22 by 7, or any number that can be written in P by Q form. Or it can also be 2 also, or it can be 1 also. Why? Because 1 is nothing but just 1 by 1, or 2 is nothing but 2 by 1. So this is a fraction here. So rational number means any number which can be written in fraction. That's the simplest definition of rational number. But rational number can also be defined as non-terminating and repeating. Let's take an example. If you have 2.3333 and so on, this is a non-terminating but repeating, because if you see here, you see 3 is repeating over and over again. So this is non-terminating repeating. So if a fraction is non-terminating and repeating, we can say that that is a rational number, because later we'll learn how to represent a non-terminating number. So now, what is irrational number? Irrational number, simple definition, is any number which cannot be written in P by Q form. Which cannot be written in P by Q form. Or irrational number is non-terminating and non-repeating. So what is non-terminating, non-repeating? If you have a number like 246.93568 and so it's going on, and you see that none of the numbers is repeating, so we call that as non-terminating and non-repeating. And again, irrational number can also be defined as any number which cannot be taken out of the root of 5, root of 7. So any number which cannot be taken out of the root, we call it irrational number. So simple term, let me just give you a revision. Rational number means any number which can be written in P by Q form such that Q should not be equal to 0. That means denominator should not be equal to 0. Because if denominator is equal to 0, then the fraction is not defined. So any fraction, any number which can be represented in fraction is rational number. But again, this numbers, integers, or so to say 2, 3, 4, 5, 6, all those we call it rational number. Again, rational number can also be defined as non-terminating. If a number is non-terminating and repeating, we can term that as rational number as well. But if a term is non-terminating and non-repeating, then in that case we call it irrational number. Or if a number cannot be taken out of the root, we call it as an irrational number, in simple terms. Okay, now under rational number, irrational number ends there. Okay, so under rational number there's two things. One is fraction or non-integers, so, and the other one is integers. So what's the difference between those two? Fraction means any number which can be written in 2 by 3, 4 by 5, all those are fractions, or we call these things as non-integers, because integers are those numbers which are 2, 3, 4, 1, minus 1, minus 9, minus 11, all those numbers are integers. So which means integers means it shouldn't be in fraction. Remember that. Now integer can be divided into integer is divided into two parts. One is negative number and the other one is whole number. Negative number means integer has two things. One is positive integers and negative integers. So these are negative integers. What are negative integers? This is -1, -2, -3, and so on. All those numbers are negative integers. What is whole number then? Whole number means this one. 0 along with all the positive number, we call it whole number. Under whole number, that means whole number means if I'm to represent whole number is 0, 1, 2, 3, 4, 5, and so on. That's a whole number. Again, under whole number, there's natural number. What is natural number? Natural number means 1, 2, 3, 4, 5, 6, and so on. So simplest definition of natural number is all the counting numbers, we call it natural number, because we don't count 0, or we don't start counting from 0, or we don't count 2 by 3, 4 by 5. We don't count like that. We just count 1, 2, 3, 4, 5, 6 like that. So which means all the counting numbers are natural number. So rational number has two things. One is fractions and the other one is integers. Under integers, it can be divided into positive integers, or negative integers and whole number. And whole number can be divided into 0 and natural number. That is first part of the numbers. Again, number can be divided into two things. One is even number and the other one is odd number. What is even number? Even number means all the numbers which are divisible by 2, or numbers which are ending by 0, 2, 4, 6, 8. So if a number is divisible by 2, or if a number is ending by these digits, that means if these numbers are in the unit place, then we call that as an even number, and the remaining other we call it odd number. Okay. Again, number can be divided into these forms. Numbers can be divided into prime number and composite number. There is only one number which is prime as well as even, which is 2. 2 is the only number which is prime as well as even. Okay. Now, when we talk about prime number, simple definition is which has only two factor. Only two factor. What is only two factor? What do we mean by this? Only two factor means that number is in the multiplication table of 1 and that number itself. That means we have only two factors. Let's take an example of 13. 13 is a prime number. Why? Because 13 is in the multiplication table of 1 and 13 only. That's the reason why we call 13 as a prime number. Now, then what is composite number? Composite number means the numbers which are not prime number. So, which simply means if a number has a factor of more than 2, that means if we talk about 4 is in the multiplication table of 1, 4 is in the multiplication table of 2, 4 is in the multiplication table of 4. That means 4 has a factor of 1, 2, and 3. 4. So 4 has 3 factors. So composite number means the number which has more than 2 factors are called composite number. There's one number which is neither prime nor composite, which is 1. 1 is neither prime nor composite. Remember that. Now comes mixed fraction. What is mixed fraction? Mixed fraction means you might have seen this one. 2, 1 by 3. So this is also simply this one, okay? 2 plus 1 by 3. If you see this one, remember that it's a mixed fraction only. You can treat this kind of fraction as a mixed fraction. So whenever you are converting from mixed fraction to proper fraction, you multiply this 2 plus this one. 3 2s are, this denominator will remains the same here, but you multiply for the numerator. 3 2s are 6 plus 1 will give you 7. I'll give you another example. If you have 3 1 by 4, you multiply the denominator and this one, and after that plus the numerator. Okay, so denominator still remains the same. 4 3s are 12 plus 1 is 13. 4 into 3 is 12 plus 1 is this one. Let's take another one. If you have 4 3 by 2, in that case, if I'm to reduce this, 2 will remain in the denominator. You multiply this 2 4s are 8 and plus 3. 8 plus 3 is 11. So the mixed fraction, if I reduce this one, I'll get 11 by 2. That's how we reduce a mixed fraction. If you see this kind of fraction, 2 plus 1 by 3 kind of fraction, you just multiply this 2. 3 2s are 6 plus 1 is 7 by 3. So if you simplify this one, you will get this one. Now I'll just discuss an important point here. Whenever you see fraction in the numerator, then how do you treat that? If you have a fraction in the denominator, you just write it like that, 2 by 3 into 4. But if you have a fraction in the denominator, so let me just use 2 divided by 3 by 4. If you have a fraction in the denominator, in that case you need to treat like this. 2 into, you write the reciprocal of the denominator. That means this denominator will become numerator and this numerator will become here. So when you have a fraction in the numerator, you will just treat it as it is. That means denominator still remains in the denominator. But when you have a fraction in the denominator, you need to write the reciprocal of that one. Okay, keep that in mind. Let's try some questions which were asked in the previous year's exams. If you look here, this is from NSSB, okay, NSSB PYQ. You have a set of fractions and you are asked to arrange it in the ascending order. That means from the smallest to the greatest. So you're asked to arrange in the ascending orders, and the fractions are 3 by 5 and 5 by 8 and 16 by 25 and 4 by 5. So there are many ways to do, but I feel like the easiest way and where you won't get confused is the simplest one is you just divide it. The denominator, the numerator should be inside this one, divided by 5. 0 point, because this is not divisible. 5 point, how much is 30? 5, 6 are 30. I have 0.6 for this one. What about this? 8 divided by 5. Oh no, what am I doing? 5 divided by 8. 0.50. 8 nearby. This one is how much? 6 are 48. 20. 5 neighbor 20 is 8 2s are 16. You'll have 4 here. 48 5s are 40. That means you will get this one as 0.625. What about this one? You have 16 divided by 25. So which means 0.25 into 4 is 100. 6 is 25 into 6 is 150. So which means I have 10 here. So which means 100. 25 into 4. That means 0.64. What about this? You have 4 divided by 5. 0.4 into 5 into how much is 40? 5 8s are 40. This one is 0.8. Now we can see the numbers here, so we can arrange this one properly. So it's arranged only because this one is the smallest number, and after that this one, after that this one, and after that this one. So we also find then which one will be the third number. So which one will be the third number? This is first, second, and third, which is 16 by 25. The answer here is this one. Now I'll leave this one for you. You arrange, or should we just try? We have 2 by 3, we have 3 by 4, we have 4 by 5, we have 5 by 6. So let us reduce this one. 2 divided by 3, 0.20. 3 6 are 18. 20, it will go on 0.66, so on. I'll just stop there. Next is 3 divided by 4, 0.30. How much? 28. 4 7s are 28. 28, and again 20. 4 5s are 20. So which means 0.75 is the value here. What about this? 4 divided by 5, 0.5 into how much is 40? 5 into 8 is 40, which is 0.8. What about this, which is 5 divided by 6, 0.6 nearby 50 is how much? 6 8s are 48 divided by, which is 20. 6 3s are 18. So which means I have 0.83. I'll just stop there. Now if you look around, what's the difference between the biggest and the smallest fraction? So which one is the biggest? This one is the biggest, and which one is the smallest? If you look around, this is the smallest. The difference between the biggest and the smallest fraction. So we need to find subtraction of this one. So if you look here, the LCM of 6, you have 6 as a denominator here, 3 as a denominator here. So the LCM of 6 and 3 will be 6. Why? Because if you look at this two, if the greater number is in the multiplication table of the smaller number, then the greater number will always be the LCM. So 6 is the LCM. So 5 into 6 times, how much is the LCM here? LCM is 6. 6 times 1 is 6, right? 1 minus 2 into 3 times, how much is the LCM? 3 times 2 is the LCM. Or 3 times 2 will give you 6, which is the LCM, okay? We can view like this. Real number is the set here. Under real number, there is two things. One is rational number and irrational number. So, but under rational number, there is integers under it. And under integers, there is whole number under it. Under whole number, there is natural number. So you can clear concept here. You have a clear cut concept here. One thing we can say is all the natural number is whole number, and all the whole number is integers, and all the integers are rational number, and all those numbers are real number. Okay, are we clear with that? Okay, now let's go to representation of rational numbers. You might have learned this one regarding this one, but I'll discuss in a simplest form like this. Let's say if you have, in this question, we have 0.333 like this, but if you just have 0.3, how will you represent this one in PYQ form? I can represent this one in PYQ form by 3 divided by, since this is one place point, that means you always count from here, okay? So one place point here, if you count from here, then it is one place point means I need to put 10 here. So if it is 0.3 only, then I can represent in PYQ form by 3 divided by 10. What if it was 0.33 like this? 0.33, it can also be represented by like this. There will be a small dash above the number. We call that as a bar. 0.3 bar means that number is repeating again and again and again, okay? So how do we represent this? Just like we did here, I'll be using the same concept here, but a little bit twisted here. 3 divided by, since a number is repeating, what I'll do is for every repeating digit, I'll write 9 here. Here, what we did was for every number after the point, we put 0 here. But in this case, for every repeating digit, I'm putting only 9 there. So if I reduce this, 3 ones are 3, 3 threes are 9. So the answer here is 1 by 3, which is the B by Q form of 0.333 and so on. This was asked in NSSB once, okay? Next, what about this? Remember, this is type number 1. And why type number 1? Because here you see that all the digits behind the point, it is repeating. What if one of the number is not repeating then? If one of the number here is not repeating, we see that 7 is repeating. So I can write this one as 0.17 bar. But bar can be written only above 7. Why? Because only 7 is repeating, not the other number. So what I'll do is, I'll apply the same rule. This can be written as, I'll just write 17. But remember, in this kind of question, you subtract the term which is not repeating, okay? From the number, that is from this number, you subtract the number which is not repeating. I'm subtracting the number which is not repeating. 1 is not repeating here. That's the reason why I'm subtracting 1 there. If you see here, you have 1, 7, 7, 7, and so on. We see that 7 is repeating, but 1 is not repeating. 1 is not repeating. So I'm subtracting 1 from that. And divided by, since one of the digit is repeating, I'll write 1 there. And one of the digit is not repeating. I'll put 0 there. Why? Because we know that 0.3, we write 3 divided by 10. Why? Because one of the digits is not repeating. That's the reason why we put 0 there. So since one of the digit here is not repeating, that's the reason why I'm putting 0 here. And why am I putting 9 here? Because 7 is repeating. Are we clear with this? So we can simplify this. 16 divided by 90. So 2 8s are 16. 2 4s are 8, 2 5s are 10. That means 8 divided by 45 is the answer there. Clear with this? If you're clear, you can give a thumbs up. Okay. Let's go to the next now. What if there was a number ahead of the point now? Okay. Earlier there was, if you look here, there was no number ahead of the point. Now, if there was a number ahead of the point, then what will we do? In this case, everything's same, okay? But you just treat it this way. Excuse me one second. Actually, one of our friend is getting difficulty with the sound. Okay, if you have a number like this, what we will do is 3, okay, you write the number that is ahead of the point, and after that you put plus 0.2222 and so on. So we have the answer here because we know how to represent this one, and this one I'll just write this way. So 3 plus, how do we represent this? 0.2 bar. 3 plus, if this number is repeating, how do we represent? We write 2 divided by, since only one number here is repeating, only 2 is repeating. So what I'll do is I'll just write only 190. So if you have a number like this, you treat it like a mixed fraction also, fine with that. 9 3s are 27, 27 plus 2 is 29 divided by 9. Or if you don't follow me with that, the LCM here is 9, and 3 into 9 plus 2. So whenever you see this kind of equation, you treat it as a mixed fraction only. You multiply this 2, and after that plus this number. If there was a minus sign here, you multiply this 2 minus this number. So that's how we solve a bit faster than usual. Okay, are we clear with this? So that's the answer there. Now let's discuss about continuous fraction. When we talk about continuous fraction, let me take an example here. 1 divided by 1 plus 1 divided by 1 plus 1 by 4. If I have a fraction like this, how would I solve them? There are many approaches to this. You can solve this one by the normal simplification approach, also fine with that. But without that also, I'll show you a shortcut method to solve this one. But before that, let me do like this. How many ones are here? You count. 1 and 2. So I have, or before that, let me just approach by the normal approach. So if I am to do by the normal approach, what I'll do is 1 divided by, I'll solve one fraction at a time. That means I'll solve this one first, okay? But before that, let me discuss one thing before there. Yeah. If you have fraction like this, 2 divided by 3 divided by 4, then what you do is you just write this one as 2 divided by 3 into 4 only. But if you have 2 divided by 3 divided by 4, then since you have a fraction in the denominator, you need to write the reciprocal of that. That means 4 by 3. So if you have fraction in the denominator, what we do is we write reciprocal of that. So that concept you need to keep in mind, okay? Now that's what I'm going to use, that concept. 1 divided by 1. So I told you earlier, you treat this kind of fraction as a mixed fraction. So if I treat this one as a mixed fraction, 4 ones are 4 plus 1 will be 5 divided by 4. And we see that this number is in the denominator and is in terms of fraction. So what should we do? We write the reciprocal of that. 1 plus 4 by 5. Same thing. If you look here, you see a fraction in the denominator. So if you see a fraction in the denominator, what we do is we treat it as a mixed fraction, which means 5 ones are 5 plus 4 is 1 divided by 9 divided by 5. I'm multiplying this to 5 ones are 5 plus 4 will give me 9 divided by 5 there. And we see that we have a fraction in the denominator. What do? We see a fraction, so which means we write the reciprocal of that, which is 5 by 9 as the answer there. So now, then how do we represent this one in terms of by shortcut approach? I'll give you the shortcut approach. I'll just keep my answer here and I'll write the shortcut approach here. First, you write the number here, 1 by 4. Remember, you write the numerator first, after that you write the denominator. You write the numerator first, after that denominator. How many ones are there you count? This one, okay? This part of ones. 1, 2. I have 2, so I can give 2 dash there. After that, you do continuous sum. 1 plus 4 will give me 5. 4 plus 5 will give me 9. So the answer here is, since we have written numerator first, that means this number here is the numerator here now. 5 divided by 9 is the answer there. I hope you're following that. Let me insert one more tab here. Let's try one more question. 1 divided by 1 plus 1 divided by 1 plus 1 divided by 1 plus 1 divided by 5. If you have a continuous fraction like this, then how do you do? First, what we do is we write the number. We write the number down, which is 1 and 5. And we count how many ones are there ahead of the sign, okay? We have 1 here, 2, and 3. So I'll keep 1, 2, and 3 dash there. After that, I'll just sum the number continuously. This one plus this one. 5 plus 1 is 6. And this one plus this one is how much? 1 plus 5 is 6. And 5 plus 6 is 11. And if I sum this two, plus, okay? 6 plus 11 is 17. So the answer here is 11 divided by 17. Are you guys not following? That's the answer there. You can type in if you're not following, or you can unmute yourself and you can. Okay. Let's go to next then. Once more. Okay. I think, what is it? I think 17 by 11. Is it 17 by 11? I'll repeat once, okay? After that. I don't think it will be 17. It will be 17. If it was like this, 1 plus 1 divided by 1 plus 1 divided by 1 plus 1 by 5. Then you will get the answer 17 divided by 11. You will get that answer like that. But by this approach, I don't think you will get 17 here. What I'm doing is, you write this one, numerator and denominator. That means numerator first, after that denominator. After that, how many ones are there ahead of the sign? So I have 1, 2, and 3. So 1, 2, and 3, I've given dash here. After that, I'm doing continuous sum. 1 plus 5 give me 6 here. And 5 plus 6 gives me 11 here. And if I sum this one, 6 plus 11 gives me 17 there. So the answer here is 11 divided by 17. Okay. So let's go to divisibility rule now. Yeah, when we learn, it's very easy. When we talk about divisibility rule, then in this case, I'll start with 2. A number is, we can say that a number is divisible by 2 if the unit digit is, that means if the number is ending by 0, 2, 4, 6, and 8. That's very easy. Let's go to next. by 3. We say that a number is divisible by 3 if the sum of the digit is divisible by 3. What do we mean by this? I have an example here. The sum of the digit means the digit here is 1, 3, 2, 3. So the digit here is 1 plus 3 plus 2 plus 3. If I sum the digit here, that means the digit here is 1, 3, 2, and 3. So if I sum this digit, how much are we getting? 3 plus 1 is 4, 4 plus 2 is 6, 6 plus 3 is 9. Is this number, is 9 divisible by 3? Yes, right? So which means if the sum of the digit is divisible by 3, then the number, this one, 1, 3, 2, 3 is divisible by 3. Are you following that? If the sum of the digit is divisible by 3, then the number is divisible by 3. So sum of the digit here is 1, 3, 1 plus 3 plus 2 plus 3. So which means if we sum this, we are getting 9 here. So this 9 here, this is divisible by 3 because 9 divided by 3, 3 3s are 9. So which means since this number here is divisible by 3, therefore this one is divisible by 3. Let's go to 4. If the last a number is divisible by 4, if the last two digit is divisible by 4. If the last two digit is divisible by 4, that means what's the last two digit here? In this case, even though the number is very long, you just look at the last two digit. The last two digit here is 64. 64. You divide it by 4. If it is completely divisible, then we say that that number is divisible by 4. Let's check. 4 ones are 4 and 24. 4 6 are 24. Since the remainder here is 0, which means that 64 is completely divisible by 4, which means this number 2323564 is completely it's divisible by 4. Are you following that? The last two digit, okay? So before next is by 5. By 5 means if a number is ending by 0 and 5, that will not, I don't need to teach there. If a number is ending by 0 and 5, that means the number is divisible by 5. What about 6? We say that a number is divisible by 6 if the number is divisible by 2 and 3. 2 and 3, okay? Let me take an example here. Let's say I have 216. Is 216 divisible by 6? We asked. In that case, I'll have to check by 2 and I'll have to check by 3. Let me check by 2. 2, it is ending by 6, which means it is an even number, so which means it is divisible by 2. But what about 3? How can we check that this number is divisible by 3? I need to sum 2 plus 1 plus 6. That means 2 plus 1 is 3, 6, 9. So which means 9 is also divisible by 3. So which means since this 216 is divisible by 2 and 3, which means that this number 216 is also divisible by 6. So for divisibility by 6, what we do is we check for 2 and 3. So if you want to know whether a number is divisible by 6, we check for whether that number is divisible by 2 or 3. Next, for 7, we don't use often in exam, and we don't see any question based on this one. So I'll just leave that aside. Okay, you can just go through and understand something there. That's the reason why I just wrote it down there. By 8, if the last 3 digit is divisible by 8, so the relation is like this. For 4, it was the last 2 digit, and for 8, it will be last 3 digit. Okay, so if you have a number like this, let me just take this number. This number may not be divisible by 8 also, I don't know. But the last 3 digit is how much here? The last 3 digit is 324. So let me check. If I want to check whether 5948 324, if I want to know whether this number is divisible by 8 or not, then I'll take the last 3 number here, 324, the last 3 digit, okay, and check whether it is divisible by 8 or not. 8 nearby 32 is how much? 8 for the 32, and we have 4 here. We have a remainder here, which means this cannot be divisible by 8. So which means that this number is not divisible by 8 because we have a remainder here. So that's how we check. You just check the last 3 digit for 8, okay? For 9, it is exactly the same as 3, okay? How? If the digit sum is divisible by 9, then that number is divisible by 9. Let us take 3, 7, 1, 4, 5, 2, 9. If the sum of the digit is divisible by 9, okay, sum of the digit here is 3 plus 7 plus 1 plus 4 plus 5 plus 2 plus 9. Let us sum this one. This one, 3 plus 7 gives me 10, 9 plus 1 gives me 10, and 5 plus this one gives me 9 there. So 20, 29, 30, 31. So 31 is what I'm getting. So I'm getting 31. If my sum is not wrong, then is this 31 divisible by 9? No, right? So which means this number is not divisible by 9. Since the sum of the digit is not divisible, the sum of the digit is not divisible by 9. Therefore, this number here is not divisible by 9. Are we following that? I hope I'm making clear of these points, because we'll be using this one. I have some question based on this ideas, okay? If the now for 11, okay, if the digit sum of even places and odd places, difference is divisible by 11. It may sound a bit confusing, but let me just write like this: 4, 3, 8, 1, 7, 2, 9. The statement says the sum of the even places and odd places. So what I can do is, this is odd places, this is even places, this is odd place, this is even place, this is odd place, this is even place, this is odd place. Remember, we are not talking about whether this one is odd number or this one is even number. We are not talking about that. What we are talking is, we're talking about their place here. This is 1, which means 1 means odd place. And what about this? This is second place, which means this is even place. This is third place. That means this one is odd place. This one is fourth place. That means this is even place. I hope you're following that. So the sum of the even place and odd place. So I'll just circle the odd places here. Odd places are these things. So sum of the odd places is 4 plus 8 plus 7 plus 9. If I sum this one, 4 plus 8 is 12. 12 plus 9 is 21. 21 plus 7 is 28. So the sum of the odd places, I'm getting this 28. And let us find for an even place here. For even place, it will be 3 plus 1 plus 2. Even place here is 3 plus 1 is 4. And 4 plus 2 is 6. So if we subtract this 2, if I subtract this 2, okay, the even place, this is odd place, and this is even place. The subtraction of this 2, which means 28 minus 6, I'm getting how much? 22. Is this number divisible by 11? Yes, right? 22 is divisible by 11. Therefore, the number here, 4381729 is divisible by 11. I hope we're clear with this. If you're confused, you can type in repeat. I'll repeat again. How is it? Because the most important concept is 11. Okay. Okay. So you figure out the odd places and even places first. First thing you need to do is, for me, I feel like it is more easier to circle even places or odd places, any of them. Or in simple words, you circle a number alternately. 4 here, 8 here, 7 here, and 9 here. So after that, I'm summing the terms here. 4 plus 8 plus 7 plus 9. I'm getting 28. The sum of the odd places here, odd places, not odd number, okay? Odd places here is 28. Now I'm going to find the sum of the even places. Even places is 3, 1, and 2. Even places 3 plus 1 plus 2, which I'm getting 6 there. The statement says if the digit sum of even place and odd place difference is divisible by 11. Difference, that means I need to find the difference of these two. So 28 minus 6, which I'm getting 22 there. So is this 22 divisible by 11? Yes. So which means the number here 4381 is divisible by 11. Okay, let's try to apply this concept in some questions here. So the question here is, actually this question was asked in CGL. I think it was in the year 2022, I guess, or 2021. The question is, the number, this one is divisible by 3, both 3 and 11, that is option number 1, divisible by 11 but not 3. That means I just need to check whether this number is divisible by 3 and 11. So let us check by 3. 3, divisibility rule of 3 was what? Sum of the digit. 1 plus 5 plus 6 plus 3 plus 2 plus 4 plus 1 plus 2 plus 3 plus 4 plus 3 plus 5 plus 1. Wow, I hope I won't miscalculate. Let's start. This one is 6. 6 plus 6 is 12. 12 plus 3 is 15. 15 plus 2 is 17. 17 plus 4, 4 is 21. 21 plus 1 is 22. 22 plus 2 is 24. 24 plus 3 is 27. 27 plus 4, 27 plus 4 is 31. 31 plus 3 is 34. 34 plus 5 is 39. 39 plus 1 is 40. I'm getting 40 there. You check once whether my calculation is wrong or not. So by first statement, I see that the sum of the digit 40, I know that 40 is not divisible by 3. So which means let's eliminate some options here. Option number A is eliminated because divisible by both 3 and 11. Divisible by 11 but not 3. So this can be the option, neither or divisible by 3. So which means I have eliminated 2 options. I have 2 options here. Now, let us find the even terms and odd terms sum. So even places here is 1, odd places here is 1, 6, 2, 1, 3, 3, 1. So let's check that. 1 plus 6 plus 2 plus 1 plus 3 plus 3 plus 1. Let us sum and check. 3 plus 1 is 1 plus 6 is 7. 7 plus 2 is 9. 9 plus 1 is 10. 10 plus 3 is 13. 13 plus 3 is 16. 16 plus 1 is 17. I'm getting 17 for odd digit sum. And for even, let's check. 5 plus 3 is 8. 8 plus 4 is 12. And 12 plus 2 is 14. And 14 plus 4 is 18. 18 plus 5 is 23. I'm getting 23 there. So if I subtract this to 23, the even place sum I'm getting 23, and odd place sum I'm getting 17. If I subtract this to 23 minus 17, I'm getting here how much? 3, 3, 6. I'm getting 6 here, which means this 6 is not divisible by 11, which means that it is neither divisible by 3 nor by 11. So that's what we are getting. Okay. Are we clear with this? Let's try one more question. I believe we will see this kind of question, not the earlier one question, but this kind of question, because we see question similar with this one in UPSC as well. Okay, so let's try to understand this. There is a 7-digit number, which is this one. This is a 7-digit number, is divisible by 72. So which means this number here is divisible by 72. But what is given? What is the least value of this one, x plus y, which simply means that what will be the lowest value? I'll just write this way: 5, 6, x, 3, 4, y, and 4. What will be the lowest value of 6 of this x and y that is asked? So you need to find the least value possible here. But before that, we need to simplify something here. I have 72. We have learned about divisibility rule, but not about 72. But can I break the 72 into 2 parts? 72 is nothing but 8 into 9. 8 9s are 72. So if this number here is divisible by 8 and divisible by 9, then I can say that it is divisible by 72. So which simply means that, in other words, this number should be divisible by 8 as well as 9. Can we start with 8? So this number is divisible by 8 only if when the last 3 digit is divisible by 8. Last 3 digit here, 4y4. I don't know the value of y here. Then what should we do in that case? What I can do is, since if the question says the highest value, you start with 9. If the question says the least value, you start with 1 or 0. So can we start with 0 here? 404. Because the least value, I need to check for 404, I'll check for 414, I'll check for 424, I'll check for 434. The smallest divisible. So let's start with 404. Is 404 divisible by 8? 8 5s are 40 and 4 here. That means it is not divisible. So this is not applicable now. What about 414? Is 414 divisible by 8? Let's check. 8 5s are 40 and 1 4. It is, again, it is not divisible. That means 414 is also not divisible by 8. What about 424? Is this divisible by 8? 8 5s are 40. That means I have 24. 8 3s are 24. That means this is completely divisible, which means that this 424 is divisible. So I'll stop there. Now what I'm getting here is that I'm getting this value 2. Y value is nothing but 2 now. Are you following that? So I don't need to check for furthermore. There may be numbers which will be divisible, but I just need to find the least one, the smallest one. Okay, so that's the reason why I'm stopping here. Start from 0 and after that and so on. But if this one says the greatest, then you start from 9, 494. If it is greatest. Okay. Now the y value here is 2 now. But I need to check for what? I need to check for 9 as well. I know that this number here, it is divisible by 8 as well as 9. So let me check for 9. What was the divisibility rule for 9? All the digit sum should be divisible by 9. That's the only thing. So 5 plus 6 plus x plus 3 plus 4 plus y here, I'll put 2 now because I know that y least value is 2. 2 plus 4. So if I sum this one, 5 plus 6 is 11. 11 plus 3 is 14. 14 plus 4 is 18. 18 plus 2 is 20. 20 plus 4 is 24. So the sum here is 24 plus x. 24 plus what value gives you a number that is divisible by 9? 24 plus how much gives you? The closest value here is how much? Can I say 27? So 24 plus how much will give you 27? You may ask me where from this 27, because 27 is the closest value that is multiple of 9. That's the reason why I'm using 27 here. So 24 plus how much will give you the closest multiple of 9? You need to check for that. So 24 plus 3 will give me 27 there. So now what I'm getting is I'm getting the x value as 3 here. Now I have the value of x is 3 and the value of y is 2. We are asked to find what is the least value of x plus y. The least value here is 2 and the least value here is 3. So which means we have 3 plus 2, which is equal to 5. The answer here is 5. Yes, correct. Anyone? Any doubt? If you want me to repeat, you can type in repeat. I'll repeat again. If not, we can move on. Why was divided first? Why can you repeat? Why was divided first, not x? Actually, what I'm doing here is I'm checking for why here, because I'm checking for 8 first. Okay, you can check for 9 first also fine, but in this case for 9, you need to know the sum of this one. And if you don't know two places, if you have two unknown values, then it will be very hard to figure it out. So that's the reason why I'm finding for this y value first, because it is very easy. You just take the last three terms. You need to check whether this last three terms is divisible by 8 or not. So that's the reason why I'm checking for the 4y4. And y, I'm inserting starting with 0, after that 1, after that 2, and after that 3, and so on. So you check until you get a number that is divisible by 8. And since the question says the least value, you will stop for the lowest value there. Okay. So I'll leave this one for you as a homework, but I'll just explain a few things here. What's the least value of x plus y is asked. But remember one thing here, it is divisible by 88. Divisible by 88 means it should be divisible by 8 as well as 11. So you check for this two combination and get your answer. Okay. I'll leave that for you. If you have doubts regarding that, you can ask in the group that we have, WhatsApp group. You can DM there. Now let's start with HCF and LCM. HCF we know it's a highest common factor. So in simple words, we can say that common number in their factor, or the greatest number that divides each of them. Common number in their factor, or the greatest number that divides each of them. What do we mean by this one? Greatest number that divides each of them. If you have, let me take an example of, if you have, or let's solve one question, HCF, yeah. Directly, yeah, let's solve this one directly here. You are asked to find the HCF of this one, and this one. One thing you can do is, you can use the approach that you know, which is 108. You find the factor of this one. You find the factor of this one, that means factor of 72. If you find the factor of this, 2 3s are 6, and 2 6 are 12, 2 1s are 2, 2 1s are 2, 2 8s are 16, 2 9s are 18, 3 3s are. So if I write this one down, I'll have 2 into 2 into 2 into 3 into 3. But let me tell you one thing here. In this kind of question, this rule is not applicable. Because what about this 2010? It's very hard to find the factor of that. It will be very long. What do we do in that case then? I'll mix up with LCM, okay, this one. So LCM was the least number divisible by all the numbers. The least number divisible by all the numbers, which simply means that a number, the LCM of that number should be in the multiplication table of all the numbers. If you have A, B, and C. If you also find the LCM of this one, the LCM here should be in the multiplication. That means this, let's say this one is 24, and if you have 3, 4, and 6, that means this 24 here is in the multiplication table of 3, and this is also in the multiplication table of 4, and this is also in the multiplication table of 6. Why? Because we can say that this 24 can be the LCM there. Are you following that? So LCM, though, nothing much to discuss, but for HCF, if the number is a huge like this, then what do? You just solve like LCM only. 108, 2010. We know how do we find LCM? We find like this. So would it be possible to keep? Let's see, because actually in my laptop, sometimes there used to be technical errors with the sound. So I'm recording as well. If fine, I'll provide, but not in YouTube. I'll be providing in through Drive. So I'll try to provide if there's no technical issues, okay? But try to attend on live class until unless there is a network issue, okay? So I'll start with this. I'll start with 2 3s are 6, 2 6 are 12, and 2 5s are 10, 2 4s are 8, 2 10s are 20, and another 2 5s are 10. But remember here, I need to put 1 0 here. Why? Because I'm taking these two together. If you are taking two terms together, not at the first, okay, at the middle or at the last, if you're taking two terms together, you need to put a 0 there, okay? Again, you look at the term here, these three terms. These three terms, is it divisible by 2? No, right? Or what I can do is this three term divisible by 3? Can we check? I know that this will be divisible by 3. What about this? 5 plus 4, 9. It is divisible by 3. 5 plus 1, 6. That means this is also divisible by 3. I can go by 3. 3 ones are 3, 3 twos are 6. And 3 ones are 3, 3 6 are 24. And 3 threes are 9, 3 threes are 9, 3 fives are 15. Now again, you go until all the three uh, until you have a number that can divide this three number, okay? You will stop when if you don't have any number that can divide this three of them, okay? Three of them. A number can divide this two, but not this one, then you'll have to stop there and you multiply this one, that will be your HCF. But here, let's check whether this number is divisible by 3. 12, yes, but 16, no. That means I can stop here. Why? Because this number and this number, it is divisible by 2, I know. But this number is not divisible by 2. Why? Because it is ending by 5 there. So there is no such number that can divide 3 of them. So what I can do is, the HCF is the multiplication of this 2. 2 into 3, which is equal to 6 there. Are we clear with that? So that's how we find HCF, but LCM is like this. LCM, if you have 1, 4, 4, 3, 6, 0, 4, 5, 0, you go until you get the simplest value, or until you get the lowest value. So, or until you get two co-prime number or three co-prime. You have three terms here, that means three co-prime number. What is co-prime? That means there is no common term that can divide three of them, or there is no common term that can divide both of them. HCF was, there is no common term that can divide three of them, you stop there. LCM is, you stop when there is no common term between at least two of them, okay? There is no common term between these two, which means you can stop there. So shall we start with this? You can start with 2 here. 2 sevens are 14, 2 twos are 4, 2 ones are 2, 2 eights are 16, and 0. 2 twos are 4, 2 twos are 4, 2 fives are 10. Again, this number, since this 2 is divisible by 2, I'll go by 2 again. 2 threes are 6, 2 6 are 12, 2 nines are 18, 0, and 2 ones are 2. This is not divisible by 2. 2, 2, 5 here. Again, what about this? I'll start with 2 again. 2 ones are 2, 2 ones are 2, 2 eights are 16, and 2 fours are 2 fives are, and 2, 2, 5. If you look here, I cannot use 2 now. Why? Because this one is divisible by 2, but these two are not divisible by 2. So I cannot use 2 now. Can I use 3? Let me check. 8 plus 1 is 9. That means 18 is divisible by 3. What about this? 5 plus 4 is 9, which means that's also divisible by 3. 3 6 are 18. 3 ones are 3. 3 fives are 15. 2, 2, 5. So you look at this one again. I can go by 3. Why? Because this number is divisible by 3 and this number is divisible by 3. At least 2 should be divisible by 3. Okay, so which means 3 2s are 6, 3 5s are 15, and 2 2 5. Now I can go by 5 now because we have 5 here. We can divide by 5 here. 5 2, I'll bring it down. 5 ones are 5, and 5 4s are 20, and 5 5s are 25. So you have a value here, which is the LCM of this one is, I'm stopping here. Why? Because there is no such number that can divide 2 and 45 until unless it's 1. 1 can divide 3 of them, but not 2 of them here. Okay, 45 and 2, we cannot divide by any number. So the LCM of this one is 2 into 1, 2, 3. 2 into 3 is 1, 2. 3 into 3 into 5 into 2. 5 into 2 into 45. So if you multiply this one, you will get the LCM. I'll leave that for you, okay? Let's not waste time multiplying that. I'm just telling you the concept here. Are we clear with that? So in HCF, if the number is very huge, what we do is we stop when a number cannot divide three of them. When a number cannot divide three of them, then we stop there and we multiply this term. In LCM, we go until and unless a number cannot divide at least two of them. So if a number cannot divide this two, that means I can stop there, or this three of them, I can stop there. So I just need to multiply this term, and that is the LCM there. What about LCM of a fraction? We can expect this kind of question. LCM of a fraction, because everyone knows now, though everyone know what is LCM, HCF, and everyone is trying to learn that. But the question they can twist is, especially in NSSB, because NPSC, there is less chance that they can ask this type of question. If asked in NPSC, then NPSC, you won't ask this type of question. But in NSSB, it's high chance that you will ask question based on fraction. But if you ask me, what about NPSC? NPSC, they can ask from this concept here, this one. But NSSB, in this one. LCM of a fraction is nothing but LCM of a numerator divided by HCF of denominator. HCF of fraction is nothing but HCF of a numerator divided by LCM of denominator. So if you are asked to find LCM, then LCM should be in the numerator and HCF should be in the denominator. If you also find HCF, then HCF should be in the numerator and LCM in the denominator. Let's try some questions. LCM of 3 divided by 8, 5 divided by 16, and 7 divided by 2. We are asked to find what? LCM. So LCM rule was LCM of numerator divided by HCF of denominator. Can we find? Let us find first the LCM of numerator. What is numerator? Numerator means this one, okay? These are numerators. And denominator means this one. The lower one, we call it denominator, and the upper one, we call it numerator. So numerator here is LCM of numerator, so which means LCM of 3, 5, and 7. What is it? Remember, all these three are prime number. If all the numbers are prime number, the LCM will be just a multiplication of that number only. Multiplication of all the numbers will give you LCM. If all the numbers are prime number, or if all the numbers are co-prime, okay? So 5 3s are 15, and 15 is 7, 7 5s are 5, 5 3 9, 7 7, 8 9 10. So 105 is what I'm getting. LCM I'm getting. LCM of the numerator is 105. Let us find the HCF of the denominator. What is it? 8, 10, and 2. By the shortcut rule, what do we do? 8, 10, and 2. 2 4s are 8, 2 5s are 10, 2 1s are 2. There's no such number that can divide 4, 5, and 1. So which means I can stop here, which means HCF here is 2. By 16. Oh, yeah. Thank you. It's 16 there. So which means where is it? Thank you. So if this is 16, 2 8s are 16. But we can stop here. Why? Because there is no such number that can divide 4, 8, and 1. 3 of them, okay? Because you have 1 here, that means you will have to stop there. But by the traditional approach, what we do, 8 can be written as 2 into 2 into 2. 16 can be written as 2 into 2 into 2 into 2. And 2 can be written as 2 into 1 only. I can write into 1 also. Fine. So what's the common term here? I just have only one common term, or I have another common term which is 1. So 1 doesn't matter in multiplication. 2 into 1, which is equal to 2. HCF, by the traditional approach, we approach this way. There you look for what is common here. You have 2 here, you have 2 here, you have 2 here. You cannot take this 2. The number should be in the factor of all the 3 numbers. So the answer here is 2. So what is the LCM of this one? LCM of the numerator here is how much? 105 divided by HCF of the denominator here is how much? 2. So the answer here is 105 divided by 2. Are we clear with this? So just before your exam, we all know how to find LCM and HCF. So what you do is, you just before your exam, you go through the formulas of how to find the LCM of a fraction. So I'll leave this one for you. Remember, greatest common multiple, which simply means you are asked to find HCF. Okay. So now let's try one question. In NPSC, they can ask this type of question. This is LCM kind of question, okay? But the way they approach is this way. How many numbers between this one and this one? 400 and 800 is divisible by this one, 4, 5, and 6. How do we approach this kind of question? You need to find a number. You need to find the numbers between these two that is divisible by 4, 5, and 6. Let me take a next example here. First, you find a number, just like we were using 72. 72 is divisible by 8 and 9. So if the question says, find a number that is divisible by 8 and 9, then I will find this one. So in this case, we are asked to find a number that is divisible by 4, 5, and 6. That means I need to find the LCM of 4, 5, and 6. I'll get a number here. And I need to check how many numbers are there between these two that is divisible by this LCM, by this LCM here, by this LCM here. Okay. So let's give it a try. I hope you understand when we solve. Let us find the LCM. LCM of 4, 5, and 6. What's the LCM of 4, 5, and 6? 2 2s are 4, 5, 2 3s are 6. So I can stop here. Why? Because this 2, there's no common term that can divide any of them. So which is 2 into 2 into 5 into 3. So 4 5 are 20, 20 into 3 is 60. The LCM here, so the number here is nothing but 60. So we need to find how many numbers between 400 and 800 that is divisible by 60. Okay. Now the question was, how many numbers between 400 and 800 that is divisible by this one? Now I've reduced this question to how many numbers between 400 and 800 that is divisible by 60 now, because the number that is divisible by 4, 5, and 6 is nothing but 60, because that's the LCM there. Then how do we check? It's a simple term only. You just use 400, you divide it by 60. You divide it by 60. You can divide this way or you can divide this way. Fine. 0 0 cancel. 6 nearby 40 is how much? 6 8s are 48. But before that, just before 40 is how much? 6 7s are 42. Oh, so which means lower than 40. You find for a number that is lower than 40. Lower than 40 is how much? It was 7, so which means 6 6 is 36. So I'll do like this. 60 into 6 is 360. 60 into 7 is how much? 60 into 7 is 6 7s are 42. So which means our counting starts from here, 420, because this 360 is below, 360 lies here. 360 is below 400. I need to find a number between 400 and 800 only. So let us check for upper limit. The lower limit here is 420. So let's check for upper limit now. 60 into, can we check for 12? 6 2s are 12, 2 1, and then 6 1 are 6 7. I'm getting only 720 there, which means I can go beyond that. 12, 13, 14. Let's check for 14. 6 4 are 24, 4 2, and 6 1 are 6 7 8. I'm getting 840 there. So just below that, let's check for 13 there. 6 3s are 18, 8 1 in hand, 6 1 are 6 7, 780. So the upper limit here is 780. Our lower limit here is 420, and it will go on till 780. But remember, 6 times how much is 420? 7 times. So 7 times, 8 times, 9 times, 10 times, 11 times, 12 times, and till 13 times will be your answer here. Because the 60 times 13 is how much? 780. So it will go deal 13 times. So what do we have here? We have 60 times 7 is 420. So it will start from 420. 420, 60 times 8 will be some number between this one. It will be 480. And next 9 times, 10 times, 11 times, 12 times, and 13 times is 780. And 14 times it is 840. That means 14 times is more than 800 because I just need deal 800 only. So that's the reason why I'm stopping here at 13. So then how many numbers are there? This is 1, 2, 3, 4, 5, 6, 7. There is 7 numbers that is divisible by 4, 5, and 6, which lies between 400 and 800. Are we clear with this? It's an important question. Even in exam, my brain doesn't work. My brain works only when I teach. Let's go to next now. Okay, I'll tell you a small concept here. HCF of two number is 12. Which one of the following can never be the LCM? You always remember this. HCF of, let's say you have two number, HCF of a two number, let's say I have A and B. And let's say LCM of A and B is, let's say A and B is C, okay? I have an HCF of A and B, which is this one. LCM of A and B, I have this one. One thing to remember is HCF will always, HCF will always, how should I approach? This number here will be completely divisible by HCF always. That means this number here will be a multiple of HCF only. That means the A, B, and C. C means the LCM of A and B here. The LCM of A and B is C here. So HCF can divide this one, and this one. Or in other words, this tree, the number here and the LCM will be a multiple of the HCF, of that HCF. So we're going to approach this question that way. You have 12 here. You ask to find which one of the following can never be the LCM. The question can also ask this way. Which of the following can be the LCM? And you will just change the options here. But in this question, you are just asked to find which of the following can never be the LCM. Is 72 multiple of 12? 72? Yes. Why? Because 12 into 6 is 6 root of 12, 1 and then 6, 1 and 7. 12 into 6 is 72. That means this is possible. This can be an LCM. What about 60? Yes. Why? Because 12 into 5 is 60. So which means this can also be an LCM. What about 90? Is 90 possible? Let's cross check. 12 into 6 is this one. So 7 to the 14, 4, 1 in hand, 7 on the 7, 8. I'm getting 84 here. That means 12 times 7, this is possible, which means the only number which is not possible to be an LCM of the two numbers. I don't know the two number here. I don't know the value, what are the values there. But just by using the HCF here, since HCF can divide this one, and this one, that's the reason why I'm saying that here 90 cannot be an LCM, can never be an LCM. Why? Because 90 is not a multiple of 12. Are we clear with that? So it's a very good concept to keep in mind. Now, let's start with this one. Excuse me once. My laptop. Okay. I haven't written down the formula here, but the formula here is this one. LCM into HCF is equal to A into B. That means HCF of a two number into LCM of a two number is nothing but the product of the number itself. Remember, this rule is applicable only for two number, okay? only for two number. Clear with that? So before going to this question, I'll discuss a question, and after that, let's go to that question. List. Okay. Let me take an example of 12 and 6. I have two number here, 12 and 6. If I want to find the LCM of 12 and 6 is how much? 2 6 are 12, 2 2 3s are 6, and 3 2s are 6, 3 1 are 3. So the LCM here is 12. The LCM of 12 and 6 is this one. What about HCF? HCF of 12 and 6. 2 6 are 12, 2 3s are 6. And 3 2s are 6, 3 1s are 3. So I can stop here. Why? Because I have 1 here. So what is it here? 2 into 3 is equal to 6. The HCF here is 6. Our formula says LCM into HCF is nothing but the product of the two number. The LCM into HCF of the two number is nothing but the product of the two number there. So what is the number here? LCM is how much? LCM here we have 12, and HCF here is how much? 6. And same thing, the number was 12 and 6 only. So which will give us the same value. So that's the concept here. But remember, this one is with a variable. Let's try this question here. I'll write the formula here. HCF into LCM is nothing but the product of the two number. The ratio of two number is this one and this one. We are given two number, but it is given in terms of ratio. So what I'll do is I'll just assume the two numbers is the first number is 6x. I'll just assume this one, and the second number is 7x. And the HCF is given. So which means HCF is given as how much? 3. So can I write like this using this formula? HCF is 3 into LCM I need to find equal to A into B. A is how much? 6 in 6x into 7x there. Without using x also, fine with that. LCM is equal to 6x into 7x divided by, if I transfer this 3 to the other side, it will go in the denominator here. 3 2s are 6. That means 2 7s are 14x squared there. I'm getting x squared. Or without using x also, you can solve this one. I'll just remove this x, okay? X here. Because some may get confused with this. LCM, I'm getting it as a 14. But what are the options? In your option, is there any 14 there? No, right? But remember one thing. Earlier, I was using x here. This 6 and 7, it is in terms of ratio. That means this is not the exact number that we have. So which means it will be 14 times something here. So which means if any of them is a multiple of 14, then I can say that that number is divisible by 14. So 14 times, let me check for 9. 4 36, 6 3 9, 9 1 9, 12, 126. So which means directly just by multiplying this one, this 126 is a multiple of 14, which means I can say that this can be the LCM of this two number. Remember, 6 and 7 is not the exact number here. 6 is to 7. So the number can be this way. In this way, it will be, the number will be 56. No, not 56. 54 is to 54. The number here will be 54 and 63. You can cross check later. The number here will be 54 and 63. Why? How can I say that? Why? Because earlier I've assumed that 6 times x, 7 times x. X here is nothing but 9. Why? Because 14 times 9 is, we are getting this. So we were getting 14 times, oh no, it will be 3 here. Well, let's not go that way. It's okay. It will be 3. 6.63 are, the number will be not 54, but it will be 6 3s are 18 and 7 3s are 21. It will be 18 and 21. So we can go to next now. Wow, how many slides are we left with? It's already 1.5 hours, 7 to 8, 8, yeah. Fine, we're going fine. Now let's try this question. This is a variety of question under LCM and HCF itself, okay? Maybe this is important for NPSC, not NSSB. The least number which when divided by this one leaves a remainder 3 in each case. How do you solve this kind of question? The simple way is this. Least means LCM. LCM of 4, 9, and 12, or we have 15, 12 and 15. Always remember when there is a remainder, you just plus 3 there. That will be the answer. You find the LCM of 4, 9, 12, and 15 plus each of them has a remainder 3, so which means you plus 3 there. That's the answer. Nothing much to solve here. So let us find the LCM of 4, 9, 12, and 15. I'll start with 3. 3 3s are 9, 3 4s are 12, 3 5s are 15. I'll go with 4. 4 1s are 4, 4 1s are 4, and 5. So if I multiply this, I'll get 4 3s are 12, 12 5s are 60, 6 3s are 18, 180. So the LCM here is nothing but LCM of this one. I'm not going in detail regarding finding the LCM because we have discussed a lot. LCM of this one, I'm getting it as 180 plus 3, which is equal to 183. So if you see a question like this, you find the LCM of all the terms and plus the remainder of each cases, okay? So that's how you approach. Next, what about the greatest for HCF then? Greatest possible number, which when divided by this one leaves a remainder, this one and this one. So in this case, same thing here, you just subtract this one. You need to find HCF because it says the greatest means highest. But the trick is this one. From this number, 37, you subtract the remainder, this one. Again, from this number, you subtract the remainder. So 37 minus 2 is 35, and 58 minus 3 is 55. After that, only you will find the HCF of 35 and 55. I'll repeat again. Remember, these are the types of question that can be asked, okay? Types of question. So if the question says, in your question, if it may be 3 terms also fine. Even though there are 3 terms also, you just subtract each term and you get the value. So you have 37. In this case, you are getting a remainder 2 there. In this case, you are getting a remainder 3 there. So 37 minus 2, we are getting 35 there. Again, 58 minus 3, we are getting 55 there. So you find the HCF of this two, that is the answer. So how do you find the HCF? 35, 7 into 5 is 35, and 55, it can be 11 into 5. So the common term here is 5. That means HCF of 35 and 55 is nothing but 5. So the answer for this one, the greatest number possible is 5 there. So that's how you approach to a question. For this one, this is a little bit different from the first one. The first one was we have a remainder 3 in each case. But in this question, we have 3 numbers here and we have 3 different remainders here. In that case, how do we do then? If you have 3 numbers and if you have 3 different remainders, then what we do is we find this. Just like HCF, 18 minus 2, I'm getting 16. And 35 minus 19, again, I'm getting 16 there. 42 minus 26, I'm getting 16 there. So what you will do is you find the LCM of this 3 number, 18, 35, 42, and after that you subtract the common remainder here. Common remainder here is 16. So that is the answer. That is how we approach this kind of question. If if you are given any number of term, here in this case, you have 3 number and you have 3 remainder. That means for every number, if there is different remainders, then what we do is we subtract and check. Remember, every time you will get a common remainder there or the same remainder there. So from the LCM of the number, from the LCM of the number here, from the LCM of this one, you subtract the common remainder, then that will be the answer there. Okay, I'll leave that for you. Now let's start with surds and indices. When we talk about surds and indices, there are some few concepts you need to keep in mind. AM divided by, so let me take an example here. I have, let's say, 2 to the power 4. Remember, this 2 is nothing but we call this one as base. And this one is exponents, or we can say this one is power. Okay. So what do we mean by exponent and power? This means that this base here is repeating. The power here says that this number is repeating 4 times. That is 2 to the power 4 means 2 is repeating 4 times. This rule number one says like this. If you have two numbers, 2 to the power 4 divided by 2 to the power 3, then what we do is if you want to write in just one term, if your base is same, then we just subtract their powers. So if I subtract their powers here, then what am I getting? I'm getting 2 to the power 1 here. So it's simply like this only. 2 to the power 4 means 2 4 times. 2, 3, and 4 divided by 2 to the power 3 means 2 3 times. 2 into 2 into 2. So 1 cancel, another 1 cancel, another 1 cancel. I'm left with only 1 here. Why am I teaching you this rule? Is because if you have 2 to the power 1000 divided by 2 to the power 696, then in that case, how will you write 2 1000 times? In this case, you apply the rule 2 to the power 1000 minus the denominator here 696. Remember, the numerator should be written first, only the denominator. Okay, so that's rule number 1. Now let's go for rule number 2 here. Rule number 2 is multiplication. If you have 2 to the power 4 into 2 to the power 6, then if there's a multiplication sign between the two numbers and their base are same, then we add their powers. 4 plus 6, 2 to the power, which means it is 2 to the power 10 there. So when there is division, remember, please make it, I'll rewrite this one. This one is strong. A to the power m minus n. Okay. When there is division, there is subtraction. We subtract the powers, and when there is addition, when there is multiplication, there should be addition in their powers. That's number 2. Next is, actually this terms is important for NSSB. We see lots of questions based on this one. I'll give you one question which was asked recently. If you see a number, if you 2 to the power minus 1, if there is a minus sign in your power, which means that that number is in the denominator. What if it was 2 to the power minus 3? Then it is 2 to the power 3. Minus represents that the 2 is in the denominator, and this power represents that the power of that number. So let's say I have 5 to the power minus 10, which means 1 divided by, why 1 divided? Because this minus sign represents that 5 is in the denominator, and 10 here is the power of that. So 5 to the power minus 10 is nothing but 1 divided by 5 to the power 10. So minus represents that that number is in the denominator. What if you have like this now? If you have a to the power, let me use a number here, 4 to the power 1 by 2. 1 by 2 means square root, okay? 1 by 2 means square root. What about if you have 4 to the power 1 by 3? That means it is cube root. What is square root? Square root means if a number is repeating 2 times, we take 1 out of the root. Let's say I have 8 here. If a number is repeating 3 times, so 8 can be written as 2 into 2 into 2. Cube root means if the number is repeating 3 times, only then you can take 1 out of the root. So that is cube root and that is square root. So if you have in your power, there is fraction, this denominator will represent the root of that. But what if you have like this then? It can be like this also. 2 to the power 4 divided by 2. Then what do we mean by this? This means that it's a square root. In square root we don't write, because 2 here represents square root, and this upper here represents the power of that number. If there's 3 also, it will be 3 to the power 4, like that. Okay, so power means if there's a fraction, if there's a number in your denominator here in your power, then that means it will represent root. And if there's a number here, if you have 2 like this, that belongs to the inner number there. And any number to the power 0 will always give you 1 only. If you have 1, 2, 3, 4, or 1, 0, 5, 6, 3 to the power 0, it will also be 1. So any number to the power 0 will give you 1 there. This one is also not that important, but this one is important. If you have root over 2, root over 2, root over 2, and so on till infinity, what we do is the answer is that number itself. So if there's x root over x root over x root over and so on till infinity, then in that case the answer is that x itself. Okay. Oh, I've missed out one term here. If you have like this, x plus root over x plus root over x plus and so on till infinity, then if there is a plus sign, if there's a plus sign, it will be the greater number. But what if you have a minus sign like this? X minus root over x minus root over x minus and so on till infinity, then it will be the smaller number. What do I mean by this? Let us take an example. 72 plus root over 72 plus root over 72 and so on plus so on till infinity. If you see this kind of fraction, first thing what you do is you need to find two numbers when multiplied, which gives you 72. But when subtracted, it should give you 1. So you need to find the numbers. Two numbers multiplied, you need to get 72, and subtracted, you need to get 1. In this case, I can say it is 9 and 8. 9 8s are 72, and 9 minus 8, it will give me 1 there. So which means I have two numbers here, 9 and 8. But the answer, this two answer depends on this one. If you have a plus sign, if you have a plus sign, that means the greater number. So the answer for this one is 9. Why? Because there is a plus sign here, which means the greater number here is 9. So the answer is 9 here. What if the question was minus sign there? 72 minus root over 72 minus root over 72 minus and so on till infinity. Then your answer here will be 8. Why 8? Because there is a minus sign here. So if there's a minus sign, the smaller number. So you can try a number here. I'll give you a homework here. Root over 12 minus root over 12 minus root over 12 minus and so on till infinity. You find the value of that. Okay. Are you clear with this concept? Yes, no? If you are done, we can start with, wow, very smart. Yeah, it's 3. Now I'll start with square root. I'll show you a shortcut way of finding a square root. How do we find a square root? There are some rules here you need to, which will make it easier for you to get a square root of a number. Square root, if the unit digit, if the number is ending by 1, then it will either have 1 or 9. The square root of that number will either have 1 or 9. And if the unit digit is 4, then it will either have 2 or 8. 5, then it will be 5 only. If it's 6, then it will either have 4 or 6. And if it is 9, then it will either have 3 or 7. And if it is 00, then it will be 0. What do I mean by this? If you have a number square root of 1391, then the unit digit here is 1. If the unit digit is 1, then the square root of that number will have a unit digit of either 1 or 9. That's number 1. Number 2 is, if the number here 244, let's say like this, the unit digit here is 4, so the square root of this one will have a unit digit of either 2 or 8. And again here 5, if a number 245, then the number here is, and this square root of, if you also find the square root of this one, the root here, the number here is ending by 5, that means the square root of 245 will have a unit digit of 5. Why? Because 5 means 5 there. Or if a number is ending by 6, then in that case it will, the square root of that number will either have 4 or 6 in its unit place. And if a number, the square root of a number here is ending by 9, then the unit digit will either have 3 or 7. Let's try some questions. At a time you understand much more better. I'll just bring this one down here. Here, we are asked to find the square root of 3364. 3364. We are asked to find the square root of 3364. Here, what is it? The number here is ending by 4, which means the square root of this number will have a unit digit of what? I have two options here. It will end by either 2 or it will end by either 8. Because if there is a unit digit of 4, that means the unit digit here is 4, then it will, the square root of that number will either have 2 or 8. That's number one thing. So just by looking at the unit digit, what I'm getting is I'm getting two numbers here. And next, what you will do is we will divide, oh, it's 4 here, okay. We will divide 2 to each from this side, okay, from this side. 6, 2, and 2. And you take the first two number here. First two number here is 3, 3. And you find where does 33 lies. 33 lies between which square and which square. What number square and what number square? Can I say it is 6 square is 36 and 5 square? 33 lies between 5 square and 6 square. Why? Because 5 square is how much? 25. And 6 square is how much? 36. So we see that the first two number, you just take the first two number here, okay? The first two number here. After taking the first two number down here, the first two number, if you check, you see that that number lies between 5 square and 6 square. So the smaller number here will be your first digit. The smaller number here, it is 5. It will be your first digit. So we have formed the number, but we still don't know whether the square root of this one is either 52 or 58. Then how can we decide which one is the answer? Next step is you multiply this one, 5 into 6. 5, 6 are 30. And you take this number and you compare it with this one. You take this number and you compare it with this one. If the number here is greater than this one, okay, if the number here is greater than this one, you will go for the greater number. If the number here is smaller than this one, then you will go for the smaller number. In this case, you see that the number here, it is greater than the multiplication of this two, which is 30 here. So this one is greater, which means the greater number is the answer. So the square root of 3364 is nothing but 58. 58. Why 58? Because when I compare this two, I'm getting this one is greater. That's the reason why the greater number here. Are we clear with this, or do I need to repeat again? Can you try this question? Square root of 6724. At least I want to finish this topic because we are very much limited with time. So we are coming to an end. Don't worry. And square root is important, especially for NSSB. Last year, they asked us this one. Square root of 361 NSSB. If you are thorough with square and square roots, you can directly tell that's the square of that number. Anyone trying? Square root of 6724. Since the number is ending by 4, which means it will either have 2 or 8 in its unit place. 2 or 8. Oh, all the numbers are ending by 4. It's okay. So which means it can either be 2 here. Yeah, some are getting 82. Anyone getting that? 82. Okay, let me check then. Yes, I think 82 is the answer. For the ones who are not following, let's cross check. I have two number which is either ending by 2 or it is either ending by 8 there. So I'll divide 2 to each. I'm dividing 2 to each. After dividing 2 to each, what do we have here? We have 67 here. 67 lies between which square and which square? 8 square. 8 square is 64 and 9 square. So which means the first digit here is 8. So 8 into 9 is 8 9s are 72. So you compare this two. If you compare this one and this one, we see that this one is smaller. So the smaller number here is the answer, which is 82. So the answer is 82 here. What about this? 361. If a number is ending by 1, it's under 20 only, okay? But just since we are doing this rule, if it is ending by 1, then it will be it will either have 1 or 9. So we have ending by 1 and ending by 9 here. I'm going to divide 2 and 1 here. So which means 3 lies between which square and which square? 3 lies between 1 square and 2 square. So this will be 1 here, this will be 1 here. So we have two options, either it is 11 or 19. I'll multiply this to 1 2s are 2. This one is greater here, that means the answer here is 19. So square root of 361, which is nothing but 19. That was asked in NSSB. Are we clear with this? Shall we move on to cube root? Okay, let's move on to cube root now. For cube root, same thing, I have some rules here. If it is ending by 1, then it will be 1. If it is ending by 2, then it will be 8. If it is ending by 3, then it will be 7. If it is ending by 4, then it will be 4 only. If it is ending by 5, then it will be 5. If it is ending by 6, then it will be 6 only. If it is ending by 7, then it will be 3. If it is ending by 8, then it will be 2. And if it is ending by 9, then it will be 9. And if it is ending by 000, then it will be 0 there. So this is the rule. Same thing. There's only one difference here. If it is ending by 2, then it is 8. If it is ending by 8, then it is 2. And if it is ending by 3, then it is 7. And if it is ending by 7, then it is 3. So let's give it a try. We can bring this one down. Let me just let's give it a try. Cube root of 4096. Cube root is much more easier than square root. Always remember that. In square root, what we did was we were dividing 2 to each. So in cube root, cube means 3 times, right? So you divide 3 to each. 3 and 3. If this number is ending by 6 means what? Ending by 6 means 6 only. So which means the number will end by 6. We have only one option here. In cube root, we just have only one option. But here, the difference is this one. This, you divide 3 to each, okay? And the first part here, we just have only 4 here. So 4 lies between, earlier was square. So 4 lies between which cube and which cube now? Which cube and which cube? Can I say this? 1 cube and 2 cube? Because 1 cube is 1 and 2 cube is 8. So which means 4 lies between 2 1 cube and 2 cube. So the same thing, just like the earlier one, the first number here, that will be the answer. So cube root is very easy. If you know this one, you know this rule, you'll get the answer. Can you try this question here? You try this. Cube root of 54872. Give it a try. 54872. Since it is ending by 2, which means the number will be ending by 8. And if you divide 3 each, you'll get like this. And you just need to find 54 lines between which cube and which cube. 3 cube is 27. Yes, 38, correct. And 4 cube is 64. So which means the lowest number here is 3. So the answer here is 38.